I'm Jon. Is that the right way? Yes. Plan for tonight. Let's talk about what we're going to do tonight. I'm going to tell you who I am. I mean, more than Zarina did. Then we're going to talk about why you should care about serverless, why you want to use it, different types, dev, test, security, yada, 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 downsides, should you use it, because I like that graphic. PaaS and SaaS, because I had to add that in because it was in the blurb and I forgot that I put that in the blurb. Future thoughts, and then Carl's going to buy everyone beer. No, but you've got the corporate credit card. Well, then Carl's going to collect everyone some beer. Who am I? That's me. There we go. I'm Jon. Hi. I'm lead cloud engineer at Logicata. It's, I'm on brand and everything. It's on the sleeve. I'm an AWS serverless community builder, which is a much better category than operations because it's a proper category and not a catch-all. Wherever the feed is, Jason, I'm sorry, I don't really mean it. And I'm also the co-founder of the Brighton AWS user group, which Carl is the other one. And if you want to connect with me on LinkedIn, that's what that's for. I've gone hard on the QR codes. I'm not sorry. Quick thing on Logicata, we are an AWS partner. We do managed services on AWS, helping customers, primarily in the small and medium-sized businesses, kind of optimize and maintain their cloud deployments, look after their estates, help it be secure and cost efficient and all that good stuff that everyone kind of expects you to do. Another one on the community builder program, because if I don't talk about it, I won't get renewed. Please renew me. It's an international community. There's 3,500, 3,700, something in that ballpark. Community builders split across a whole bunch of different categories: serverless, data, operations, containers, machine learning, yada, 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 yada. You get to hear early announcements and things from product teams, subject to NDAs, so I can't tell you about them. You get some AWS account credits, which is worth it if you regularly do things and then regret paying for them, because you do get a bit of free money. There's a brilliant community. Like I say, it's about 3,500 or so in a Slack group, and there's community events and so on. So it's a very loud Slack group, so I don't really listen to it very much, but there we go. And if you want to find out more about that, that's what that QR code's for. Someone scan it, please. Not you. And I'm kind of annoyed Simon's not here because he applied and didn't get in. So there we go. I mean, it's not uncommon, right? The getting in first time is kind of rare. It's not uncommon. And then Brighton User Group, that's the other one. As I say, I'm co-founder. Carl's the other co-founder. He does a much better job selling it than I do. If you want more AWS-focused events, more deep technical, because this is kind of light and high level, scan that. You'll find us. Next meetup's on the 21st of November, and we've got Ben Smith from AWS coming down to talk about serverless. Again, it's kind of a theme because I'm a serverless builder. We do serverless. So, right, I care because I think it's fun. Why should you lot care? Well, you've got two options. Either you think it's up and coming, or you think it's already everywhere. Both of those are kind of true. What is it? In short, I mean, this is it. This is the whole talk. This is it. It's a way of doing stuff without provisioning servers. Stuff is a number of things. It could be the next phase of the cloud, or it could just be another gimmick. I don't know. It's the first one, and it's probably the second one. It's not the third. It's not going away. Can you see that? I hope you can see that. Why should you use it? Well, the first one is the age-old, that's terrible. We'll muddle through, is a greater resource density. It's the old adage of do more with less, which I'm sure everyone that's worked in tech for more than about 10 minutes has been told that. Do more with less. Spend less money, give me more stuff. Serverless is good for that. It's cheaper, usually. It's not always cheaper, but usually it's cheaper. Again, that comes down to the resource density because you're provisioning less, and there's no standing cost, which is great. You don't have to pay for it to exist. You pay to use it. You pay to do stuff with it. Yeah, usage-based charging. And dev time and speed to market. So dev time, dev speed, and time to market. Get that the right way around. Again, because you're not provisioning things, you don't have to worry about all the ancillary bits and pieces that come with it. You don't really have to care about networking and provisioning and hosting. And you just kind of go, make my code run, and it runs, which is great. And on top of that, it scales really quickly. because it scales to 0 and it will scale to full capacity within milliseconds, depending on the service, which is kind of handy. And then the last one is it's just more interesting because servers are dull. No one likes servers. Servers are dull. I'm going to rattle through these because these are, again, I've gone real hard on the smart art, so we'll see what this works like. Types, compute, this is the bread and butter. This is Lambda, really. I'm sure the other cloud providers do them, but I don't know what they're called. That's boring. I mean, you can mock AWS's service names all you like, but they're interesting. Storage, so object and file system, you're talking S3 and you're talking EFS, because yes, okay, EFS is technically serverless. You have to mount it to a server or a Lambda, and then you can use it, which is kind of cool. So it is serverless, and S3, most people should know what bucket storage is at this point. It's just blob, object, there you go, store it. And then key pair, which is not what you think of in storage, but keys and pairs, data and keys and data, things like a secrets manager, parameter store, where you don't want to keep it in a database, you don't want to keep your data on a disk, in a file, you can use that sort of thing. And again, it's serverless because you're paying for what you're storing, you're not paying for it to exist. Databases, SQL and NoSQL, obviously, because both types exist. Aurora serverless, it's a stretch. You do kind of pay for it to exist, but it's got serverless in the name, so I've gone with it. I've gone with it. It's a stretch because you do actually have to pay for it to exist, and I don't like that, but there we go. And then the NoSQL stuff is kind of cool. DynamoDB is really cool. I'm not going to go into it now, but I'll talk your ear off later if you like. More types, because there's loads of it. Web services, APIs, load balancing, thinking API gateway, thinking load balancers, obviously. Authentication, I was whinging about Firebase earlier. It did make it. It is in there. But yeah, I was whinging. DNS, every DNS. Yeah, it's a server. You've not logged onto GoDaddy's server to update your DNS. It's serverless. It just is. Unless you're Facebook, obviously. But, you know. CDNs, which, again, content distribution. Yes, it is all servers. No, you're not paying for them. Therefore, to the end user, it is serverless. Bit of a theme here. Security, firewalls. Again, all of this does technically run on servers. You haven't paid for them. To you, it is serverless. And yeah, some of these are a bit stretchy. But the scanning stuff, the security stuff, again, you pay for what it's doing. This is a bit of a theme, right? You pay for what it's doing. You don't pay for the service to exist. You don't pay for the servers it runs on. You pay for what you get out of it. Orchestration is a bit of a funny one. Queues people should be familiar with, just moving messages around between various services and bits and pieces. I've put step functions in there because if you know what they are, they're kind of important, they're kind of interesting. It's a way of doing orchestration serverlessly of serverless resources. So it's kind of 2 layers down, but yeah, that's cool. And then I've called it support services because I couldn't think of what to call it. Like logging and monitoring, I've called it a support service. I don't know if you could call it anything else, but there we go. It is what it is. Right, Lambda. I said I'd touch on it. Yeah, let's talk about it a bit more. It's the bread and butter of serverless. You say serverless, you think serverless functions. You think Lambda because that's probably the one everyone's familiar with if you've even half Googled it. Yeah, I've said that. And I thought there'd be more people in the room for this one, to be honest.
It's the rain.
It's definitely, it's the weather. It's the weather,
Yeah.
says the man with the wet hair in the back there. What is it? It's AWS's function as a service. I've said that repeatedly. The tagline is you can run code without managing servers. That's a short version of the tagline, without thinking about servers or something of that nature. It supports a whole bunch of runtimes. I've not listed all of them. The cool one down the bottom there is Docker, which means you can run anything in it. And yes, they've fiddled around with runtimes lately and they've deprecated a couple of them. And yes, you can run Rust if you want to, but I don't want to talk about Rust.
What about Go?
Yes, Go runs. Go. It goes. Go has gone, but it still goes. Yeah, for those that don't get the joke, AWS recently deprecated the specific Golang runtime, but you could still run it through functionally a bare metal container. So that's a thing. But if you don't use Go or Rust, it runs Python, it runs Node.js. So if you're writing TypeScript because you have to, you can run it there. You can run what else is it natively supported? .NET and a few other bits and pieces. It's a fully managed execution environment. And again, what do I mean by that? It means you don't have to worry about patching or provisioning or networking. You kind of tell it, I want code to run. Okay, it runs. You can worry about the networking. If you're connecting to things like databases, you kind of have to worry about it a little bit, but you haven't have to plug cables in, not really. And as long as you don't need access to more traditional resources like databases that sit in VPCs and subnets and networks and what have you, then you don't have to worry about that either. It just runs. Brilliant. And it talks to basically every AWS service in existence natively. And you can get direct calls to Lambda services, Lambda functions from, I don't know how many it is, but it's dozens of things. The obvious ones being S3 notifications, SNS, SQS, so queues, a whole bunch of other things. But it talks to basically everything in creation. So you do see it used quite a lot as a bridge, a bit of glue, just so that you can stick some services together that don't necessarily stick together very well, and you can kind of force them to, which is useful. Right, I've gone, how do you write them, as in lambdas? Yeah, you can still work locally. For the developers in the room that are going, oh, there's no servers, where does it run? You can still work locally. So you write your code as you normally would. You write your unit tests. You mock out the AWS services, again, using the SDK, as you would for anything else. And then you use either SAM CLI local or plugins for serverless YAML, which are the deployment tools, which I'll talk about in a minute. And they let you run things locally. They'll spin up containers for you, inject your code into it, run it, give you the results, tell you that your code's broken, which is what it usually does to me. You do want to sort your deployments out early, because whilst you can work locally, the execution environment is not identical. So you do need to be working in a dev environment. You need to be deploying regularly so you can test all your integrations, which is what I say there. I'm kind of being a little bit biased. I prefer native tooling to third party. That's a preference. I just think it suits it better. It fits nicer. I know our speaker at the last event disagreed with me a little bit on that one, but there we go. And definitely get a pipeline in place. For those that aren't familiar with CI and CD, that's just a way of automatically deploying, right? If you're deploying to a dev environment regularly, you don't have to do it manually. You don't have to do it by hand. You're just going to have a bad time. So get something in place that does it for you early, because otherwise you're going to feel the pain. How do you do it? Well, manually, like I say, no, just don't. You're not hiding for nothing. You can use Terraform. Anyone in the room familiar with Terraform? One, oh. No, not Open Tofu. This slide is older than Open Tofu. It's the least opinionated way of doing it, because it will talk to basically everything in creation, but that means you have to write quite a lot of code to do it. However, it's probably the quickest one in terms of deployment speed. It runs very, very quickly, but it takes you a long time to actually do all the work and write the code and so on and so on. So it's a trade-off. And I put a little note out there for Serverless TF. Shout out to Anton Babenko, who wrote Serverless TF. It's a collection of Terraform modules that help you do the kind of first two bits, really. It makes your life a bit easier because you're not having to write loads and loads and loads of code. He wrote it for you. Thanks, Anton. Next one, Serverless YAML. I mentioned it a minute ago. It's a third-party tool from, I forget the name of the company, Serverless Framework or some such. It's based on YAML. Should be happy about that, Joe. Should be happy. It's YAML-based. It boils down to CloudFormation eventually. It's just kind of another way of doing that. Most of these will boil down to either an API call or CloudFormation. Next one's AWS SAM. This is my favorite because, I don't know, I spent years writing CloudFormation, and this is pretty close to CloudFormation because, again, it's built on top of CloudFormation and it's AWS's own offering. And my logic behind using this is because it's their own offering, it might have been thought about a bit better than the other ones. Maybe. I'd like to hope. I just like it. You can use the CDK, which is the Cloud Dev Kit, which you can write infrastructure in JavaScript and scare people. Again, yes, I know. You can write it in kind of most of the languages that the runtime supports. You can use in the Cloud Dev Kit, so Python, JavaScript, TypeScript, whatever. And you can write it in SQL, which is new-ish. Any SQL devs anywhere? Yeah? You can write infrastructure in SQL. It's It's weird. I'm trying not to swear here because what I'd normally call it will get us banned from YouTube. It's odd. You write SQL, the service hosts Postgres database, and you basically write select and insert and update statements, and that maps to your infrastructure. Only supports AWS at the minute, and it's weird. It's really cool though, if you like SQL. And like I say, it's newish. It's still like v.1 or something. So but definitely check that out if you are that way inclined. Right, so now you've worked out how you're going to deploy them off of your PC or out of wherever it is you're hosting it into the cloud. How do you do that properly without pushing go on your Mac? Use something called GitOps. GitOps, Git operations, everything's a something ops these days. I don't know why. It's GitOps, it's FinOps, it's DevOps, it's flip-flops. It's ClickOps. Everything's something ops. And this is what I was talking about earlier with sorting out a pipeline, right? It still uses the CLI tools. So if you've written it in SAM or CDK or in IA SQL, because you're that way inclined and a bit mad, I might try it just for fun. It will still use the same tools, right? So you do the first bit, you work out how you're going to move your code off of your machine into the cloud, and then you write some more YAML, because this is almost always in YAML, unless you're still using Jenkins, in which case I feel for you, because join the real world. It runs in YAML. It runs the existing CLI tools that you've kind of used. So you've got to work out how to get that to work, but it's not that hard. And it will just take your code out of your source control, shove it in the cloud in the same way that you've configured with your deployment tools. Great. Obviously, you don't deploy straight to production because you're not that mad, hopefully. You deploy to non-prod, you do your normal pull requests, merge requests, do your reviews, deploy to production from there, right? That's how you do it properly. You do infrastructure as code with GitOps, and you just write about 1 million lines of YAML. Cool. Security is still a thing. You can't get away from it. Security, I don't know. It used to be I've got to do that. And then apparently everyone's like, oh, woo, security. A lot of developers are still, okay, fine. You can't get away from it. You still got to behave in a secure manner. First one is pretty obvious. You still need to write defensive code. You can't get away with things that are liable to SQL injections. You shouldn't be storing secrets in plain text. That kind of logical things, clear variables after you don't need them anymore, so on and so on. Use up-to-date runtimes. Don't use Node 12. It's dead. Stop using it. Everyone on the internet, all 6 of you. Yeah, up-to-date runtimes. There's a bunch of, like I said earlier, there's a few managed runtimes, and they will kind of be kept up to date within that scope. So if you're using Node 18, Node 18 will be provisioned up to the latest patch levels and so on. But when Node 35 comes out, Node 18, they won't force you up a version, breaking changes and so on. So just make sure you're keeping your versions up to date, making sure your code is properly tested with those. And if you're using custom runtimes through Docker, keep them up to date. They won't force you to do it because they can't tell what you're running, but keep them up to date. And don't make your functions web-facing if you don't have to. So yes, it's on the internet. Yes, it's in the cloud. And yes, you can get to it through the web. If you don't need it to respond to web requests, don't connect them. Don't put API gateway in front of it if you don't have to. Don't make a DNS record for your Lambda function URL if you don't have to, because you're just asking for trouble. Use the provided tools. So what do I mean by this? Most of the security tools that I spoke about earlier, Inspector being one of them, will scan Lambda code. It will scan. It's on by default these days, Inspector. So it will scan it, use the tools. They're there. And they're really good at catching you doing silly things, because I'm usually doing silly things. They go, no, you're not meant to do that. So yeah, use the tools that have been provided. And actually make sure you read your logs. Check your log files. Make sure you're writing sensible logs so that you know what your application's doing. You can't, even though there's no log file on a server, logs are still a thing. They're still available. With Lambda, they go out to CloudWatch by default, which is AWS's logging service. So they go out there by default. Look at the damn things. Right, cool. Downsides, because, yeah, there are some. I'm sorry, there are some. Makes me sad, though. It's a mental jump, which is probably why there's all 6 of you on the internet and all 9 of you in the room. It's a mental jump, so there's some explaining to do, right? It's not just, oh, my code magically runs. It's different. The way you work with them is different. The way you interact with them is different. The way you deploy them is different. It's all different. Your leadership team might not have worked with them before, so in terms with your developers, they've got to go on a journey to learn about them and upskill and all the rest of it. You've got to take your leaders and your managers and however many people work above you in the organization. You've got to take them on the same journey with you so that they get it, so that they understand how they work. And the question of how do I run that on my PC is not a question that you have to have regularly. You do it, you take everyone on the journey with you. Such a sales term, that. And developers, you need to worry about deployments. You can't just go, oh, it works on my machine, toss it over the wall at ops or DevOps these days. No, you can't decouple your infrastructure from your application code anymore. Yeah, okay, technically you probably could, but you shouldn't, because your code needs to know how to interact with the world it's sitting in, and the world it's sitting in is defined by the infrastructure. So they're very tightly coupled. Orchestration can be a challenge. What do I mean by this? So you might have one smallish app. It's got 15 or 20 functions. You probably will break that down because one Lambda shouldn't be enormous. So you might have upwards of 10, 15 functions to replace a smallish application. So how do those things talk to each other? How do you monitor them? Yeah, even put it on the slide. How do you monitor them? And you're talking about things like distributed tracing, and where the bottlenecks are in your code is a lot more important, because whilst you can scale the functions independently of each other, it's still not perfect. Integration tests are a lot harder. Local testing is less mature. Yes, you can still do it. You can still mock out things like the SDK. SAM CLI local is a thing. You can run them locally, but the tools are a lot less mature because they've just been around for less time, right? Certainly with Lambda, you can run them locally. Step functions, you can run it locally. You can't mock everything locally, and things like step functions, because they also call out to other services. The layer of mocks that you have to do just gets to be a bit ridiculous, and then it stops being worth the effort. So that's why you need a dev environment. That's why you need to be deploying to dev regularly. And yeah, you can write your integration tests and run them against a live environment instead. So that's kind of how you get around that. But local testing is a lot less mature. And because of this, failings in your deployment process are a lot more painful. Back in the day when you deployed once a month, if it took 3 hours, no one cared. It was once a month. If you're deploying, how many times did Netflix deploy? 24,000 times a day. If that's taking 3 hours, how many people do you need to do that? That's just insane, right? So you're deploying more components more regularly. So you start to feel what's called the bottleneck, basically the area where all your process slows down. You feel that a lot more keenly and a lot more painfully, just because you're hitting it more often. And finance teams, this is one people don't tend to think about. In the same way that finance teams don't like the cloud, because you can't accurately predict all elements of it. You can't accurately predict serverless spending because it is entirely usage-based. So unless you know exactly what your traffic requirements are going to be, what you're storing, how much you're storing, how many people you're talking to, and so on, it is functionally impossible to predict your spend. Fortunately, it's usually quite cheap, but finance teams, in at least ones that I've worked with, didn't care what the number was. They wanted to know what the number was before it got spent. So they don't like it because they can't predict it. Right? How much is it going to cost? How many people are we going to get? That's the mental arithmetic, and it's just impossible. So yeah, to serverless or not to serverless? That is the question. Yes, do it, definitely. But I like this graphic, so we're going to go through this exercise. And you can tell by the way it's done, because I couldn't get the boxes to go the other way. So it goes top down. You can see which one I'm preferring already, hence I'm also in the room. So things that are good for serverless, and that really hasn't gone well on a big screen. Right. I hope that goes well on the internet. That's
just about reading, but it does feel like an eye test.
Oh, I'm due for one, actually. Okay, that's awful, and I apologize. So serverless, if you don't know your workload patterns, or if you've got spiky load and you don't kind of know when it's going to come through, and it might come up very quickly, come down very quickly, might not do a lot for a while, serverless is good for that. If you've got low use applications, so this is either, again, things that you don't know are going to be popular and then aren't popular, or internal things that are only used some of the time, a couple of hours a day, working hours, whatever. It's quite good for that as well. Rapid go-to-market. So I spoke about this earlier, because there's a lot less infrastructure that you need to provision, in the same way that cloud did away with racking and stacking and running data centers and all the rest of it. It's doing away with all the server provisioning and your networking and so on, depending on your application. So you are just doing less. And then, of course, if you don't have any in-house sysadmins or people that understand how to run the servers and all that kind of thing, because you're not running them, you're not patching them, you're not maintaining them, they're not yours, great, go serverless. On the other side, if you have known predictable usage patterns or consistent high use. And what do I mean by this? Well, going a little bit off script here, but the Prime Video, what was it? It was the stream quality analysis team. They moved from a serverless lambda based and step function, all the rest of it, back to a quote monolith quote, because they discovered that they were spending just huge amounts of money orchestrating things, because it never scaled to zero. It never got any smaller. It was always just pegged constantly. So they spent the time and they re-architected it and they went, oh, it's a monolith. And the media cycle went completely mad with serverless is dead. It's the death. Look, even Amazon's getting rid of serverless. Microservices are dead, and the whole thing, in the way that the media loves to sensationalize, even about really dull tech. In truth, that's not what happened. The boundaries of a microservice just moved slightly. It was still actually a microservice. This just, the microservice wasn't broken down into even more microservices. But why did they do that? They did that because it was constantly pegged, really high usage, and they're paying loads of money. By merging things back together, again, it was a density thing, but it was code density and function density rather than density on hardware. It just allowed them to run a lot cheaper because they were constantly pegged, right? In the same way that the cloud is technically more expensive than running your own data center, if you're paying more, you're doing it wrong. And I genuinely believe that, and I will be, I'll die on that hill. If you're paying more, you're doing it wrong. You're using it in the wrong way. If serverless is costing you more money than servers, then serverless isn't the right thing. Maybe you're not using it wrong in this case, but it's the wrong tool, as it were. Anyhow, I had to throw this one in, so sorry for the rubbish graphic, but I forgot that I put this in the blurb, so here we go. PaaS and SaaS. Does everyone know what those acronyms are? Yeah? Cool. The internet can't nod. I'm going to assume you can. That's kind of it. The Venn diagram, which, again, that was awful to draw. Decent diagramming tools like that, just, it's horrible. Serverless is PaaS, SaaS is serverless, right? It's kind of the fingers and thumbs argument. It's you haven't paid for the resource to exist. It's serverless. Software as a service, that's serverless. You don't care where it's hosted, you're just using it. It's serverless. Function as a service, which is serverless, and storage as a service, and so on and so on. Again, you've not paid for it to exist. You've not paid for the disks. You've not paid for the compute. You've paid for the result. That's serverless. Platform as a service is things like managed databases, RDS, for anyone familiar. Again, that's not serverless. You paid for a server. You haven't had to do a lot of the maintenance, which is great, but it's not serverless. You've paid for a server to exist. Future thoughts, because I'd like to pretend I'm a futurist sometimes. Serverless is here to stay. It is still a buzzword, because you see this with like Aurora Serverless V2. It's not really serverless. I'm sorry, it's not. You have to pay for a minimum commitment, so you're paying for a resource to exist. In my book, that's not serverless. It might get cheaper. Most things get cheaper, but don't hold your breath, because it's really cheap to start with. And if you hold your breath until it gets cheaper, you'll pass out. Oh, come on, that was the first actual joke. I mean, facts can be funny.
True.
Dev will get easier as well. That's the other thing. I firmly believe that dev and local testing will get easier. New tools are coming out. AWS are working on this constantly. Like step functions, local mocking wasn't a thing, and then it was a thing. It came a long way after things like SAM CLI local. Recently in the news, we've seen SAM CLI local supporting resources to Terraform, so it's improving. It is genuinely getting better all the time. If you look at web development 30 years ago, that was awful. I say 30 years ago. I was 2, so I don't know, but I wasn't doing it then either. Frameworks have gotten better. Testing tools have gotten better. Gotten better. It will get better. New frameworks will come along. It's never going to replace servers, much as, I can be quite divisive about this and just sort of say, if, you're using it wrong, you should never use a server and all the rest of it. The servers are still going to be a thing because, I'm sorry, the serverless runs on servers. You just haven't had to deal with it. Someone else has done it for you, right? Servers are still going to be a thing. It's never going to replace them. There's always going to be workloads that need to be running hot at 100%. 100% of the time. I don't want my air traffic control system being serverless. Sorry, I just don't. The cold start on that would be awful. For those that are unfamiliar, cold start is a Lambda-specific problem. The first time you run a function, it will take longer to respond than the second and the third and the fourth time you run the function, right? And that's orders of magnitude. It's microseconds on the second and third time, and it's full seconds on the first time if you're using things like Java. So yeah, I don't want air traffic control to have a cold start. I just want it to run, please. So yeah, it's not a perfect fit for all workloads. It's kind of a bit like duct tape. It's not perfect for most things, but it will work for everything, at least for a while.